hear me now? Alrighty. So here's the thing, a funny thing that happened to us. And I promised that I'm going to start with this. See if I can get my start. There we go. Wow. So John has already told a bit about me. I'm actually a JavaScript developer, part front-end trainer, and I have a lot of open source projects. I've been working with a lot of open source projects lately. Started with Mozilla, but working with the, whoever heard of Tassel so far? Alright, so I've been working with the Tassel project, which is an open source hardware. I will be showing you one of the newest hardware pieces, Tassel 2, hopefully. This is an open source hardware, open source software project, so it very much fits the FOSDEM umbrella. And it's under the jQuery Foundation, so which supports a lot of open source projects these days. So I'm also a Mozilla rep, community tech speaker, whatever you imagine. I talk a lot about Mozilla stuff, especially Firefox OS, and I'm going to show you a few use cases of Firefox OS as well. So my talk will be about how to leverage JavaScript or web technologies on creating or exploring hardware projects. Exploring is a very nice word to use because you don't want to do this like in production. You don't want to use the Tassel or Firefox OS in production. But you want to explore new ways of doing stuff, new ways of doing technologies. And HTML5 and JavaScript was a very forgiving language or platform from the first place to just hack away, just copy and paste, and try to explore the boundaries of what's possible in the web. And I can tell you a lot is possible today in web technology. So I hope you're going to get a good appetizer into that. So I have to go with it, or start or continue with the disclaimer today. We were flying in from Singapore just recently, and a series of unfortunate events resulted in our check bags gone missing in the process, which resulted in half of my gadgets and my gadget cam that was supposed to be using for you to actually show the devices. So you will have to, you'll have to use your Googles or something like that. I hope you have a perfect vision because my gadget cam was in those missing bags as well. And that actually comes with a very nice intro to the start, which also merges into my Firefox OS's like new direction, the connected devices direction. So when we landed with our plane delayed, and we're trying to get ourselves to the different terminal, different gate to catch our plane back to from Singapore. It was very apparent that there was like these two airlines who were supposed to be working together, and they were like people like phoning around, not even knowing the phone numbers of the other airline and things like that. So what we would want to do in the future, and what we would want our devices to have, is to actually help us being connected, help us being, how connect all these different pieces. And that's what IoT about, or what IoT should be about, is actually being able to connect our stuff together and do that in a very easy way. Do it in a way that has low barrier of entry and that has like intuitive solutions to our problems. So, but how to start with that? First, actually, you will have to have devices, and those devices, whoever heard of Raspberry Pis? Well, most of you. Whoever heard of Arduinos? Okay, whoever programmed one of these or worked with one of these. See, when you start working with hardware, whoever used JavaScript on these devices. There you go. So there's actually there are devices that you could use JavaScript on. A person came up to me and asked, "Why is Rust good?" You know, Rust is a Mozilla project. Why is Rust very good? Rust is very good because it lowers the barrier of entry. Everyone can try systems programming without the need to know, memory handling or the fear that they screw up. That's exactly what JavaScript is. JavaScript lowers the barrier of entry. You don't have to worry about memory. You don't have to worry about allocation or crashes because it's a managed language, a managed memory language, and because of all these affordances, it's very easy to get into JavaScript. So the other problem or the other view into JavaScript, why is JavaScript good on hardware? JavaScript is actually getting into it's getting very ubiquitous. In the last few years, in 5 or 10 years ago, JavaScript was, you can use JavaScript to script your browser. Then Node.js appeared, JavaScript went to a server for local applications, and I'm going to show you a few applications of Node.js and JavaScript in every different form factors and devices. So it's getting ubiquitous. If you know JavaScript, you can actually do 90% of what there is out for a software developer to do, from desktop applications to mobile applications to server stacks to embedded hardware. So our first contender to this, and please find me in the you can find me today and tomorrow in the Mozilla booth mostly if you want to know more about these devices or you want to learn more about what's possible with JavaScript and hardware, web technology and hardware, and I'm going to tell you more. So what can be seen on the screen is a Espruino Pico. Everyone seen or heard of it ever? So yeah, it's no mistake. That's a USB connector. So yeah, this is the device we're talking about. This is a FOSDEM size device, and it really is running JS on bare metal. So it's so bare metal that actually it can be used. It actually runs JavaScript on source. If you know JavaScript. Mostly today, JavaScript is not transforming to an intermediate AST form and even precompiled or just-in-time compiled just to be more swift, just to increase the speed of JavaScript execution. Here are these devices which have 16 kilobytes of memory and 64 kilobytes of flash. It's not remotely possible to actually store the JavaScript source and store the compiled or syntax tree for this device. This comes with interesting implications. So when you run JavaScript on source from a limited hardware device, this is like a few megahertz processor. So imagine a scenario, you want to blink a light. You have a JavaScript API for that. You actually create a JavaScript file that says set pin 25 on. That that blinks, that sets one of the pins to on, and your LED lights up. And then you wait, a few cycles, processor cycles, and you turn it off, and you blink the light. That's like the hello world of hardware creation. Now imagine that when you run JavaScript from source, you actually have to read the data from the memory, interpret the data in on the device, and run that script code line by line. This has interesting implications because if you put more white space or comments in your code and you push that on the device, actually your code will run slower because your device has to read the memory locations. So you just set the pin, turn on the pin, push some more spaces or enters in your JavaScript code, and your blinking will slow down. That's how bare metal this JavaScript goes. And of course it has a lot of problems. 60 kilobytes doesn't even fit the whole Unicode, so it's not EX5, not even not ES6, but not even ES5 compatible in many cases because character codes don't fit there. But you can actually use and I will show you this later a bit, a web IDE that's like a Chrome add-on that you just plug it in, it connects to the device, and you can live code JavaScript. I will try to show you if we have more time. Yes. And one more, this is a bit more high-level device. Has somebody played with the Tassel 1? Alright, so the Tassel 1 is a device that actually runs very similar to the aspirated Pico. It's very similar as in it runs JavaScript on the bare metal. The Tassel 2 actually is a bit different because it contains a whole Linux environment. It's an ARM chip, 680 megahertz of ARM chip, running a whole Linux environment. And what is very nice, it has a very nice feature that you can actually run full Node.js on it. You could say, okay, whatever, I can run full Node.js on a Raspberry Pi or whatever. Why is Tassel 2 very good? So before Raspberry Pi Zeros, you would have to shell out a lot more than for a Tassel 2 because they're $35. They're just shipping. The other end is you can actually, it's built in OpenWRT. And that could give you an idea because the Tassel 2 is actually includes a built-in Wi-Fi module, and not just a Wi-Fi module that can connect to access points, but actually can act as an access point as well. This creates a lot of more interesting demo options. I will show you a demo later if we have time for that you can actually serve a access point from the Tassel 2, serve a web page from it, and connect from any device to that web page that exposes a lot of like GPIO outputs or things like that to the device. So you can actually control GPIO from a web user interface. Alrighty, and let's get to a different level. Whoever played with Arduinos? So the problem with Arduinos is that like the very basics of JavaScript hardware, the very basics of IoT hardware. They were like a jumping point from people knowing no hardware, people playing blinking lights and reading sensor data and all that. The problem with that, even though the Arduino IDE is getting better and better, you still have to know C or C++, JavaScript, and C or C++. And C or C++ can be terrible in user interface or ergonomy, not even because of the memory, but because of the limitations of the device. So you can tell people that, okay, you can actually create stuff, get into IoT by doing, Arduino stuff, reading sensors and writing to GPIO ports. What you can also tell people is you can actually get into IoT and program microcontrollers or hardware and create games, and that's where the Arduino comes in. So the Arduino is basically an Arduino Leonardo. An Arduino Leonardo is different because it has a built-in USB connection and handles USB connections from the chip itself. So this Arduino Leonardo has been hooked up to an OLED screen and some buttons. What it gives you is basically a handheld palm-sized device that you can actually use to play games. So when you have this device on with you, you just put a coin cell in it or supply power, and anything put on the device will instantly boot up. It will run the application. There was no boot up time. This is like plain machine code running on the device, and you can play the games. And what's very good about this is you can actually share the games. Here you can have a platform, you can experiment, create games, you share with people, and just with a click of a button, push it on the device. So why am I telling you all this? Because creating games is not all dandy for Arduino. For example, I'll try to show you just a bit more about this. As I find that. Okay, so let's see. So the problem with Arduino is just creating any type of data that you want to bring on the device, contrary to like creating web games or something like that. You'll have on web games you have resources, you have assets, you can push WAV files, push images, image assets on the device, but you don't have an Arduino. Just to create a simple sprite, you would have to push byte data onto the device. What you can actually do though, if you know HTML5 with JavaScript, you cannot write the C++ or C code in JavaScript. Theoretically you could, but that's a different story. What you can do though is you can ease your own job by creating actually an application that lets you create assets and ease your creation, ease your job in creating hardware experiences like creating Arduino stuff. This is just a sneak peek. If you want to know more about this, the gaming console or this project, there is a talk. My talk is on this on in the Open Game Design room in tomorrow morning something. So this is a web application, basically a web page. That you could use to create your Arduino games, Arduino projects for the Arduino. What's very special about it is that actually it's written completely in JavaScript. The web application runs on a server. It compiles your Arduino sketches on a server, so you don't need anything but a browser to actually use this. The only thing why you need a computer actually is, except for typing code, is actually to connect through a serial port to the device. But even that could be, you don't need like a proper full computer for that. You can use a Raspberry Pi or something like that to actually have your device flashed on the device. And what's very interesting about it, which I can show you because the internet connection I have doesn't seem to work, is actually contrary to those bytecodes you have in there. You can actually create an IDE. The IDE helps you when you click those that emoticon of a alien. It actually gives you a graphical user interface when you can modify the sprite, and it calculates you the data that you would have to use. The interesting fact about this, because it lives on the internet, because it's a web browser, you can actually use any other device, like use your tablet to draw your images, and let them update on the screen of your computer simultaneously. So this is like the idea of interconnectedness that goes into when you start working with the web and web browsers. You have a single language to do, you have a single language to work with, but also these devices are built on the web, so they are accessible and interconnected by default, on the contrary to any other languages. So, sorry about the lack of demos. I will try to have more demos on tomorrow's talk about the Arduino. And if you have any questions, please ask them now or find me after the talk or in the gathering. Any questions now? Alrighty. Thank you for your attention and see you around. Have a good time at FOSDEM.